Welcome back to Hardware Unboxed. Today we are revisiting AMD's Fidelity FX Super Resolution that we first covered a couple of weeks ago, because in the last few days, a number of new titles have been updated with support for FSR. Crucially, we now have the first titles in the wild that support both Nvidia's DLSS technology and AMD's FSR, giving us a proper apples-to-apples comparison of the two in the same game. I'm not going to rehash much about how FSR works, how DLSS works, and all of that. If you want a more in-depth look at FSR, we have a comprehensive video already up on the channel that tells you everything you need to know. But these are two fundamentally different technologies attempting to achieve the same outcome: more performance without a significant loss to visual quality. So it'll be interesting to see how they compare. AMD's FSR is the more simple technique. It's a spatial upscaling technology that combines edge detection upscaling with a sharpening pass. Nvidia's DLSS, on the other hand, is more complex, incorporating temporal data, including prior frames and motion vectors, and uses an AI network to assist with the image reconstruction process. Both require integration into games themselves, ideally before final post-processing and UI effects are added, and both feature several modes in their standard configuration. There are several games that are now supporting both techniques, and the two we are focusing on in this video are Marvel's Avengers and Necromunda Hired Gun. Avengers is developed by Crystal Dynamics and uses their in-house Foundation engine, similar to the prior Tomb Raider games they have worked on. Meanwhile, Necromunda is a game from Streamon Studios set in the Warhammer 40k universe that uses Unreal Engine 4. The integration of FSR in Avengers came as a bit of a surprise, as it wasn't a title AMD listed in their launch presentation, but it is nice to see. Both titles use the first iteration of FSR, which AMD are calling FSR 1.0, and they are making it pretty clear in their documentation that they'd like people to use FSR 1.0 branding in their games. Meanwhile, both of these titles use a variant of DLSS 2.0 as well, although the exact subvariant differs. Necromunda in the latest update uses one of the newest DLSS revisions, DLSS 2.2.11, while Avengers uses 2.1.52. Nvidia doesn't officially distinguish between different DLSS versions beyond 2.0, but there has been a lot of discussion about this lately. For today's video, there will be some quality comparisons of course, but first we will be looking at the performance differences, as that will inform which quality comparisons make the most sense. We're mostly interested in which modes of DLSS and FSR perform the same, rather than comparing both at the same base render resolution, which is not that relevant for real-world usage outside of for science type investigations. For the upcoming benchmarks, we have tested both Avengers and Necromunda using 3 resolutions and all the available DLSS and FSR modes using 2 GPUs, the Nvidia GeForce RTX 3080 and the RTX 2060. Both were tested using my Ryzen 7 5800X test rig with 16GB of dual-channel DDR4 3200 memory. It's a pretty typical sort of gaming rig. The visual captures you'll see later are from the RTX 3080, and for that I would recommend watching the video at 4K. First up, we have Avengers tested using the very high preset at 4K on the RTX 3080. Both DLSS and FSR offer a pretty similar performance uplift across their modes. Interestingly, in this game, the difference between quality and balanced DLSS isn't that large at times, at least in the area we tested. In any case, DLSS quality outperformed FSR Ultra quality slightly. We're seeing a 4% frame rate advantage for DLSS comparing these modes. However, when comparing FSR quality to DLSS balanced, now the equation flips in favor of FSR, which delivers 8% higher frame rates, a margin that's also held when comparing FSR balanced to DLSS performance. When comparing both at the same render resolution of 1080p, so both in the performance mode, FSR is able to deliver a 19% higher frame rate as the DLSS overhead is larger. What this means overall is that the performance gains achieved with Avengers start around the 30% mark at 4K and then go from there. At 1440p, we're coming much closer to being CPU limited when testing using some of the FSR and DLSS modes. Here FSR has the edge, with its ultra quality mode delivering 3% higher frame rates than DLSS quality, although this is a pretty minor difference all up. Then using the lower modes, there's really not much of a difference, and overall here the performance uplift that these technologies provide is only modest. At 1080p with the RTX 3080, there is no point using either DLSS or FSR, as you won't see any performance gain using either. Basically here, these are just quality reducing modes, and you should stick to the native resolution. I mean, the RTX 3080 is more than capable of playing games at 1080p without these sort of technologies. When using the RTX 2060 and high settings, this GPU is really not capable of delivering a playable experience at 4K native resolution, with the 1% low well below 30 FPS. However, both DLSS and FSR do provide a decent performance uplift, and like with the RTX 3080, DLSS quality outperforms FSR ultra quality to the tune of 9%. Like we saw previously as well, this neutralizes using the step down in quality, as DLSS balanced matches FSR quality here, and we see similar at lower modes. DLSS Ultra performance is faster than FSR performance, as it's using a 720p render resolution versus FSR's 1080p, but in these modes we are miles away from native image quality. At 1440p, these technologies still provide a decent performance uplift with a GPU like the RTX 2060. DLSS quality is equivalent to FSR Ultra quality here, and this remains true using the other modes as well. The fact that gamers using this sort of mid-range GPU can achieve a minimum of a 35% performance uplift is pretty neat, and does deliver a noticeably smoother experience on a variable refresh rate monitor. Unlike when using the RTX 3080, the RTX 2060 is much less prone to being CPU limited at 1080p, so there's more of a point to using DLSS or FSR. Again, the performance between each of the settings is much of a muchness. DLSS quality is approximately FSR Ultra quality, DLSS balanced is approximately FSR quality, and so on. The performance uplift starts at 29% better than native rendering. Then we move into Necromunda Hired Gun, where the story is quite similar when playing using the maximum in-game quality settings. With an RTX 3080 at 4K, DLSS quality is slightly faster than FSR Ultra quality on average, a 4% margin here. But that changes to a slight 2% margin in favour of FSR when comparing DLSS balance to FSR quality, and FSR continues to provide larger gains as the modes reduce to the point where FSR performance is notably faster than DLSS Ultra performance. This game benefits really nicely from FSR or DLSS as well, a 44% uplift over native using FSR Ultra quality and a 50% uplift using DLSS quality. At 1440p, DLSS quality and FSR Ultra quality are effectively identical in the performance they provide. Again, using lower modes, FSR has the advantage, with FSR quality being 7% faster than DLSS balanced, and the overhead of DLSS prevents it from matching FSR's performance at the same render resolution when comparing performance mode to performance mode. Either technology provides at least a 35% performance improvement when enabled. Then at 1080p, like with previous modes, neither FSR or DLSS provides a particularly significant improvement when using the RTX 3080, and honestly I wouldn't bother enabling it given the native performance is in excess of 200 FPS. The RTX 2060 on the other hand struggles to provide a playable frame rate using 4K maximum settings. However, both DLSS and FSR solve that problem, pushing average FPS into the mid-40s. DLSS quality is once again marginally faster than FSR Ultra quality, while DLSS balanced and FSR quality deliver virtually identical frame rates. FSR has the edge at lower quality modes, and the performance uplift on offer here is substantial, with DLSS and FSR offering a minimum 90% uplift over native resolution as 4K effectively chokes this card. At 1440p, we're back to normal programming. DLSS quality is 2% faster than FSR Ultra quality at this resolution, while FSR quality is 5% faster than DLSS balanced. With native rendering only delivering a 60 FPS experience, it's well worth using a technology like this to drastically improve performance. Then at 1080p, FSR delivers performance equivalent to DLSS using the highest performing modes, and has an advantage at the lower modes, which tends to be the story across both Necromunda and Avengers in a variety of conditions. So the performance testing we've just seen hasn't revealed anything too surprising. DLSS is a more intensive technology to run and has a higher overhead, so for a given render resolution it delivers a lower frame rate than FSR. What this means is that FSR's tier above quality setting using a higher render resolution is generally equivalent to DLSS at a lower render resolution in terms of performance. FSR Ultra quality is slightly slower than DLSS quality, but within a few percent. FSR quality is virtually identical to DLSS balanced, and FSR balanced tends to be equal to or faster than DLSS performance. Then it could go either way, comparing FSR performance to DLSS Ultra performance, not that I'd expect many to use those settings in the real world. But how do they compare in terms of visual quality? Well, let's take a look. In Avengers, when playing at 4K, I generally found it pretty hard to spot the differences between native rendering, DLSS quality, and FSR Ultra quality across the majority of the image. All three techniques look excellent, and you'll have to be looking pretty closely to spot the flaws. However, when I do look closely for these videos, I'd give the edge to DLSS quality, as it's that little bit cleaner for the finest details. I think you get the best look at it in this second scene. In general, the two images look pretty similar, but you zoom into something like this fine railing detail, and DLSS is reconstructing pixel level detail better than FSR. That's not to say FSR looks bad here, as FSR looks almost indistinguishable from the native image. It's just that in this game, for some of these details, DLSS's better ability to combine data from multiple frames gives it a better than native presentation. Probably a failing of the game's built-in TAA implementation, which, as you'll see soon, in my opinion, is a bit crap. Then when we compare FSR quality to DLSS balanced, again, it's a pretty similar story. Both deliver roughly the same performance, and I think DLSS looks slightly better here. It's in the lower modes, in static scenes like this, where something like DLSS performance is significantly better than FSR balanced or FSR performance. Now in practice, I don't think any of the lower modes truly gives native image quality, especially in motion. You'll see lots of artifacts, but there is no doubt that if you want the highest performance boost using the lower modes, then DLSS gives you superior image quality. At 1440p, I think the margin between DLSS and FSR grows slightly. DLSS quality and FSR ultra quality both look similar to native rendering, but both have their issues. DLSS has better fine detail reconstruction, as we talked about in the 4K section, however suffers from noticeable artifacting around this moving NPC. FSR also suffers from artifacting, a bit less shimmering but more ghosting, as the native TAA implementation, which is required to make FSR look even half decent, has horrendous ghosting. Crystal Dynamics really need to improve their TAA, as these issues are present even in the native image, and FSR just takes whatever artifacts are present natively and works with it. With DLSS quality looking better than FSR ultra quality at 1440p, it's no surprise that this continues to be true at lower performance equivalent modes, and especially in the performance mode. DLSS looks not great, a bit blurry, but FSR is a lot worse with artifacting in addition to blur. FSR is simply not good at upscaling from such a low render resolution. Anything below 1080p it really struggles with. Then we get to 1080p, and I'll be honest, neither FSR nor DLSS provide native image quality, even with their highest possible quality modes. I wouldn't recommend using any of these modes, as was the case when just talking about DLSS in prior videos. Again, I think DLSS looks better than FSR here, but I'd be sticking with native rendering at this resolution. There just isn't enough data to work with for an effective upscale or reconstruction. But how about in motion? Well, let's look at this scene with Thor. In prior comparisons, we saw that DLSS is better at preserving fine detail and does better than native image quality at times. Does this hold true in motion? If we zoom into this bridge section with fine wire detail, this is what native rendering looks like. It's not bad, but there is a minor amount of shimmering in motion as the bridge shifts slightly and other elements get in the way. With DLSS quality, we do get better reconstruction of these fine bridge elements in a still shot, but in motion, those lines become wobbly, which doesn't really look better than native anymore. With FSR ultra quality, the shimmering present in the native image increases, and overall I do think this artifacting is more noticeable than what DLSS does, however neither is as good as native here. What we also find with Avengers in particular is horrendous TAA ghosting. Just look at Thor in action with the native image, bad ghosting around his hammer and cape. Once again, FSR has no ability to remove that artifact, so it's still present in the FSR ultra quality image. DLSS does not have this level of ghosting, as it switches off TAA in favor of its own anti-aliasing ability. This is an example of where DLSS can fix the mistakes the developers make with their native image, while FSR relies more heavily on a developer producing a good TAA image, which is not at all the case here with this level of ghosting. If we ignore the ghosting for a moment, I think FSR and DLSS quality are very similar in how they handle most detail in motion, but that ghosting is noticeable. When using lower quality modes like FSR quality versus DLSS balanced, again, it's hard to split them in motion. Both are a little blurrier than native, both do a pretty good job of preserving detail given the reduction in render resolution, but both also suffer from shimmering with the finest elements. Meanwhile, if we compare the performance modes of both, which both use a render resolution of 1080p, it's pretty clear that DLSS delivers better image quality in motion. The level of artifacting with FSR is bad, and with DLSS also suffering from very noticeable shimmering, I don't really recommend the performance mode at 4K. With that said, like in prior comparisons, if you want to use the highest performing modes with little regard for achieving like native image quality, then DLSS is the superior choice. I'll also show motion performance here at 1440p. Whether you opt for DLSS quality or FSR ultra quality, in my opinion both are a reduction on the native image in motion, being a little bit blurrier and introducing more noticeable shimmering, although of course in some situations that will be tolerable given the performance increase. It's very hard to spot the differences in non-static scenes here, though I do feel from playing the game using both that DLSS offers slightly better image quality than FSR at 1440p in motion, with both the DLSS quality and FSR ultra quality modes delivering the same performance as we saw earlier. At 1080p, you're really not going to want to use either DLSS or FSR in motion, as both are clearly worse than native rendering, and this is much more apparent when things are moving on screen than when sitting and looking at a static image. FSR looks terrible with lots of artifacts and that annoying ghosting caused by TAA, while DLSS is very blurry, even when both are using the highest visual quality modes. Just ignore these features at this resolution unless you are desperate for more performance. Alright, so that's a look at Avengers. How does FSR and DLSS compare in Necromunda? In this game, in my opinion, it's far harder to separate DLSS quality and FSR ultra quality at 4K. Both are extremely close to native rendering, DLSS a little softer, but with slightly better superfine detail, FSR a little sharper overall, which is a look that some prefer. If anything, I feel FSR is a little too sharp, but there's no doubting that all three presentations look excellent. At lower quality modes, I think DLSS has a slight edge on FSR, but it's very close. Again, DLSS Bounced, for example, does a better job of preserving fine detail, but FSR quality is still highly usable and close to native. Meanwhile, at 1440p, again, I feel DLSS and FSR are quite close overall in their image quality using the highest modes. Again, FSR ultra quality is a bit sharper, perhaps too sharp, while DLSS quality is softer but has better fine detail. When playing the game, and in the case of Necromunda the movement is quite fast, it's hard to tell the difference between DLSS and FSR at 1440p, but like at 4K, using lower FSR modes does hurt image quality noticeably, with something like DLSS performance giving a much better image than FSR performance, though neither are as good as native. In this second scene, everything we just talked about still holds true. I think FSR at 4K using ultra quality is a tad over sharpened here, and it would be nice to get fine control over the sharpening level, or just a lower level in general. However, the image quality is just different to DLSS, which is softer, not necessarily worse. That's why I think it's hard to split in terms of what looks best, though DLSS is most similar to the native image, also a tad soft. At 1440p, we do start to see some effects of lost detail when using the FSR ultra quality mode versus either the native image or DLSS using the quality mode. For example, this distant chain is clearly lower quality in the FSR image, and I spotted this without zooming excessively. While I do think the majority of the FSR image is good enough, it's in these small areas where DLSS tends to have an edge at 1440p. I do have some motion comparisons for DLSS versus FSR, which I'll show on screen now, but I'll be totally honest, the fast-paced nature of movement in Necromunda makes it very difficult to tell the difference between most modes. To my eye, DLSS and FSR look identical in the highest quality modes in motion, with the latest version of DLSS used in the latest patch addressing a lot of the motion artifacts present in earlier versions of the game. It's only really when comparing performance mode versus performance mode that I can spot FSR providing a blurrier image. Even at 1440p, FSR ultra quality is pretty close to DLSS quality, while in my opinion FSR quality is slightly inferior to DLSS Balanced. Again, we're comparing modes that perform the same here. However, FSR does look a lot worse in modes below quality. The Balanced and performance options have a lot of artifacts, while DLSS keeps a cleaner presentation. One issue I did spot in this game is that DLSS seems to amplify particle effects to a noticeable degree. In this forge scene, the native image has a lot of fine moving particles, many of which are pixel sized or thereabouts, which are preserved to a good degree using FSR ultra quality. But then you enable DLSS and the particle count appears to be much higher. A lot of those tiny particles have been enlarged, and there's more motion artifacts like streaking, particularly at lower DLSS settings. I'm not sure whether this is a bug in the game or whether it's just an issue with the way DLSS is attempting to reconstruct this motion using multiple frames. It really hurts the image quality at a resolution like 1440p in my opinion relative to FSR. So there you have it, that's all for our quality and performance comparisons between FSR and DLSS in the same games. The ultimate question that I'm sure a lot of people have been asking is, well, is DLSS or FSR better? In my opinion, that's a hard question to answer because there are lots of factors to consider. We've got visual quality, performance, artifacts, game support, hardware support, integration, and so on. Neither technology offers the best in all those categories. But in the area that matters perhaps the most, the balance of visual quality and performance, I think that generally speaking DLSS 2.0 is better, though to the degree it's better varies significantly depending on the game and playing conditions. My overall thoughts here are actually quite similar to my initial FSR video. In Avengers and Necromunda when playing at 4K, DLSS and FSR are competitive using the highest quality modes, DLSS Quality and FSR Ultra Quality, which end up delivering roughly the same performance. DLSS is slightly better in static scenes in a title like Avengers, but in motion both are similar, and Necromunda is also very similar overall. In a lot of situations, one isn't necessarily better than the other, they just look different. For example, the differences in sharpness in Necromunda, or the way in which fine detail shimmers in Avengers. In these ideal conditions, it often comes down to nitpicking individual problems with each technology. For example, in Avengers, DLSS does provide better than native reconstruction in some areas which FSR can't match. However, in Necromunda, DLSS had issues with particle details that FSR did not. You could end up focusing on one thing or the other to make a definitive conclusion, but in the end I'd say at 4K highest quality modes they are pretty similar. In most other situations, it gets tougher for FSR. At 1440p comparing FSR Ultra Quality to DLSS Quality, I felt that in general DLSS had a small edge, especially in Avengers and to a lesser degree in Necromunda. In motion it can be hard to tell the differences, but overall I think the quality advantage DLSS provides is more noticeably better at 1440p than 4K. I do think FSR is good enough here, considering the performance uplift is equal to DLSS, though again I overall feel that DLSS is superior. Then in pretty much any other condition, DLSS is much better than FSR. Using the lower quality modes which require a larger amount of upscaling to the target resolution, DLSS delivers a sharper, better image in most situations, including in motion. FSR is particularly bad when the render resolution is below 1080p, and while DLSS doesn't look amazing in its lower modes either with noticeable artifacts in motion, DLSS is clearly the better choice for those desperate for more performance without as much care for image quality. This stems from DLSS's access to more data when upscaling. It takes information from past frames and motion vectors, while FSR does not. The greater the difference between render and target resolution, the more this advantage allows DLSS to provide better image quality. However, this also comes at a performance cost. DLSS has higher overhead than FSR at a given render resolution, which is why direct comparisons between DLSS and FSR at the same render resolution is a bit pointless, or at the very least it omits half the story. FSR's overhead allows it to be more competitive with DLSS in higher modes at the same performance as it can utilize a higher render resolution, but this advantage isn't enough to get FSR close to DLSS in more difficult cases. In games that support both FSR and DLSS, this puts each technology in a bit of a weird spot. DLSS is better when you need to run the game at lower resolutions, but GPUs that support DLSS are mid-range or better and are less likely to require DLSS's lower modes. The GPUs that would really benefit from these superior DLSS capabilities are things like GTX 1650s or even APUs, which don't support DLSS at all. Then you have FSR, which supports all reasonably modern GPUs, and while it's better than nothing on these non-DLSS cards, the best of FSR is only seen with higher-end GPUs capable of higher resolution rendering, where it has to compete with DLSS and DLSS supporting cards, so it's all a bit strange. When you factor in everything each ecosystem offers, noting FSR's superior GPU support and easier integration, and DLSS's wider list of supported games in addition to the differences in performance, I think that right now DLSS is the better overall technology offering. The gap could close if FSR was supported in more games than the small handful we have right now, as the amount of GPUs that work with FSR is certainly a tasty proposition, but right now it's hard to go past DLSS 2.0 that works better or equal to FSR in most situations and is found in more games. On an RTX GPU, for example, I would personally choose to enable DLSS over FSR in games that support both. Where this whole battle will get the most interesting is when DLSS and FSR are both widely supported in a range of titles. Will it be worth spending more on a DLSS-capable GPU, or upgrading specifically to gain access to DLSS instead of just FSR? Right now that answer is dictated mostly by game support, as in many situations it's either DLSS or nothing, so obviously you'd want DLSS, but will that be true in a world with wider FSR adoption? I'm not so sure. Anyway, that's it for this one. Another lengthy investigation into DLSS and FSR, now that they're available both in the same game. I can't imagine that we'll be looking too much more into the topic of FSR, at least for now. We might come back with a revisit sometime in the future, but I think most of the things that we wanted to investigate now have been answered with this video. So yeah, if you're interested in supporting the channel and independent hardware testing, please check the links in the description below. We've got our merch store, we got links to Patreon and Floatplane if you want to support us directly, gain access to things like Discord chat, monthly live streams, all that sort of stuff. Thanks for watching. I'll catch you in the next one.